Hey guys, and welcome to this video once again discussing the concept of rate of change and how it pertains to these real-world situations that we're going to model using graphs and tables of values and later equations. So in this example, we're going to talk about a politician named Low Botter, and he's the mayor of New York in this hypothetical example, and we're going to talk about his approval rating. And an approval rating is just what percent of people approve of the job that he's doing. And we're going to say that there was one stretch starting in March of 2008 when his approval rating grew for 8 months in a row. And on March 1st, his approval rating was 42%, meaning that 42% of the people surveyed said, yes, I approve of the job that Low Botter is doing as mayor. 7 months later, on October 1st, which is about a month before election time, his approval rating had gone up to 52.5%. And the first question we want to ask is, how fast was Low Botter's approval rating growing during that time period? We know it was going up, right? It went from 42% to 52.5%. But when we're talking about these kind of rate of change problems, we really want to know, for instance, in this case, how much did his percentage go up per 1 year? Right? When we're talking about rate of change, we usually want to know per 1 unit of whatever it is. So like miles per 1 hour. How much do you get paid per 1 day? Or in this case, how much did the percentage go up per 1 year? And so we're going to talk about this in a number of ways. And the first thing I always like to do is to sketch a graph of the situation, because I like to visualize a picture. And on our horizontal axis, well, let's discuss what our independent and dependent quantities are going to be. And in this case, I think that time, however we decide to define it, time is going to be our independent variable, and the approval rating is going to be our dependent variable. So let's make time on our horizontal axis. And let's have the approval rating on the vertical axis. And what we're going to do is we're just going to kind of visualize this growth in the approval rating, a very rough sketch of a graph, if you will. So on March 1st, the approval rating was 42%. So here we're going to make this March 1st. And on March 1st, the approval rating was 42%. So let's draw a big old dot. So if we were to draw a graph of this situation, you would definitely have a point right there. 7 months later, on October 1st, the approval rating had gone up to 52.5%. So on October 1st, the approval rating had gone up to 52.5%. You can see that I'm totally just sketching now, just so we have a picture to work with, and I like having a picture. Okay, now note that we don't have any information on what happened between March 1st and on October 1st. We did hear that the approval rating had grown for those 8 months in a row. In this case, it was only 7 months, but maybe it grew really fast in the beginning and then it kind of leveled out. Or maybe it grew really slowly in the beginning and then it shot up right at the end. And maybe it was like, the mayor said, no taxes for anybody, and people were like, woo, that's awesome. Or heck, there could have been many other situations. Maybe the mayor was super popular and the approval rating went through the roof, and then there was a big scandal and it went back down. Who knows? But this is the only information we have right now. And we're asking, basically, on average, how fast was his approval rating going up per 1 year? And I also want to make a table of values. So I'd like to start with a graph. I also like to make a table of values. And on this table of values, I'm going to put my independent quantity here, kind of like x, and our dependent quantity here, kind of like y. Now time, not quite going to cut it. Time is a little bit too vague. So let's define this to be the number of months since March 1st. And let's define our dependent quantity to be the approval rating, which of course is going to be a percent, but just the approval rating. Awesome. So on March 1st, 0 months since March 1st, the approval rating was 42%. On October 1st, which was 7 months later, his approval rating had jumped to 52.5%. All right, so the first thing I think we want to do is we want to figure out exactly how much did the approval rating increase going from March 1st to October 1st. Well, I think that it increased by, let's see, 10.5%. And how would we find that, kind of using arithmetic? Well, you take whatever approval rating he ended at and subtract where he started at, and that's going to give you the difference in the two, namely 10.5%, a positive 10.5% increase in his approval rating. The approval rating went up by 10.5. And I'm going to actually give this a variable. I'm going to call that y. And so this represents the change in his approval rating, the change in y. Okay, so the approval rating went up by 10.5%. in 7 months, how much did the approval rating go up every 1 month? Well, I think you just take 10.5 and you divide it by 7. And note that 7, that also represents the change in the number of months, which I am going to not originally call x. So our change in x was the difference in how many months had transpired, so 7 minus 0, for a grand total of 7 months. And so this right here represents, well, for a 7-month increase in time, every 7 months that goes by, the approval rating goes up by 10.5%. And we could actually carry out this division. If we carried out this division, we would get, you could write it as a fraction as 3/2, or you could even write it as 1.5. So what does this mean? That 1.5, this means that every 1 month that went by, the approval rating went up by 1.5%, right? So if, in 1 month, we'd go up to 43.5% approval rating. After 2 months, we'd be up to 45%. After 3 months, we'd be up to 46.5%. After 4 months, we'd be at 48%. And if you continued on up until 7 months later, you would, if you just counted up by 1.5, 1.5, 1.5, you would get up to 52.5% again. So 1.5, this is kind of our unit rate. Every 1 month that goes by, the approval rating goes up 1.5%. 3/2 is the same thing as 1.5, but this also means that every 2 months that goes by, the approval rating goes up by 3%, right? So from 0 to 2, it went up from 42 to 45, right? A 2-month increase, 3% increase. Or from 1 to 3, a 2-month increase, a 3% increase. So you can see how both this ratio and this number, which is still a ratio, and this ratio all show up on our table of values. They also show up on our graph. So let's first consider 10.5 over 7. For a 7-month increase in time, that politician enjoyed a 10.5 point increase in their approval rating. And what does this represent? This actually represents the slope of the line connecting these 2 points. We said we have no idea exactly how the approval rating changed, right? It could have gone up quickly or slowly or what have you. But on average, this is how fast it was growing. On average, it was growing at 1.5% per year. This is the slope of that line. And that's not surprising because we found this by taking our change in y, 10.5, and dividing it by our change in x. And that is exactly how we've been defining slope all these times. And of course, right, this also, we can find this 1.5 in the graph as well. For every 1 month that goes by, there would be a 1.5 percentage increase in the approval rating. Every 2 months that go by, there would be a 3% increase in the approval rating. So all of these ratios that represent that slope or rate of change, we can find these in the graph as well. So it's just really important for me that we understand this idea of average rate of change as representing the slope of this line, being able to find it from this table of values and do some computations and connect them all to each other, and of course to be able to describe this real-world relationship using this concept. And now that we have the slope, later we'll be able to make equations to describe this relationship as well. Perhaps you can do it right now, and I invite you to give it a try, but that will be the discussion for a later lesson.